Hi all. Let's see the concepts of byte enable concept in PCI. So in transaction layer, we discussed in last video byte enable concept. So in this concept is useful for specific location you want to read the data and you want to write the data. Based on specification, you have to enable. So in transaction layer header, we have a second double word as a first double word and last double word values. The first double word value will be the 4 bits and last double word value also 4 bits. So overall 8 bits. So in remaining will be the tag and request ID. So first double word well last double word values with suitable example we seen in last video. We'll continue with one more example for that to clear the concepts more. I took as one example here. I have a memory page having a address of 8 zeros to 8 ones. So starting with a 0 up to 255. Let's assume 0 to 255 you have a address. So let us I want to write that you have a memory that much memory you have that maximum memory you have. You want to write the data 26 bytes of data you want to write the starting with address of 2 from you are starting from 2 not with 0. So starting address will be the 2 you want to write the 26 bytes of data. So 26 bytes means each 4 by 1 d word means length 1, length is equal to 1, length is equal to 1. 1 d word means 4 bytes. So 26 bytes means length is equal to 7, right? Length is equal to 7. Minimum you should put to write the automatic data. So length 7 I should give. So length field L is equal to 7. Remaining fields will be what type of format, whether it is read or write format and types you have to choose. Three double words or four double words you choose, and TD value, UP value, it is based on your requirements. You have to choose accordingly, whether you will use ordering rules and all not. Then we'll say as a second double word we have a first byte enable and last byte enable values. We'll calculate here based on this date. You are writing data 26 byte. Based on that, you have to calculate the first double word values and last double word values. You have to replace these values to that place, that fields. So let us assume you started with 0, right? Address, but you are writing from starting address is 2. So the here will be that this will be the 2. So 2 means 1 and 0 should be disabled, right? Disable means you should give as a 0 0 0 0. Here is given 0 and 1 as giving as a 0 0. It started with the 2 up to it went as a 28. So what happened? Uh, Here you will calculate. Here this is a 4 1 divide. This is a 4 1 divide. Second divide. Third divide. This will be the fourth divide. This will be the fifth divide. This will be the sixth divide. This will be the seventh divide. Okay. Here will be the 1. Here will be the 2. Here 1. Here will be the 2. Here will be the 3. Here will be the 4. Here will be the 5. Here will be the 6. 6. Here will be the 7. So you are going to above 7. So you are giving us a 26 bytes data. So 7 is 26 byte data. Here will be the 7. 1, 2, 3, 4, 5, 6, 7 slots. So what will be the first double word and last double word value? So based on 26 bit, what is the first double word value? This is the first double word value. First double word values will be double one, double zero. This is a then after you are then what is the last double word value? Here is a crossing, right? So after that you have a data as well. So you will give let us assume there also one. So last double word value will be 3001. This is a last double word value. Your this is a up to 27. So you'll get as a 28 as well, right? So you are crossing from 27. So 28 you are enabling. So last double word value 0001. So in this way, you will calculate the first double word values and last double word values. So If you have any question, please comment what byte enable concept. So we'll continue with the next concept we call as a atomic operations useful in PCIe. So if you take one example as a you have a RC, you have a EP, you want to write the data, you will send as a request from RC to EP side with data request with data you will send, you will write the data if any specific location, specific address. If you want to read the data, again you will send as a request with a read operation. You want to read the data, you will get as a completions with the data. You will get completion means response you will get from the EP to RC side. So if you want to do two operations means you are sending from two requests from the RC to EP side. So instead of sending two requests, we'll introduce as a one more concept as a atomic operations. By using this, we can reading and writing both can happen one instruction itself from RC to EP side. So in atomic operations, we have it three types: fetch and add, swap and compare. So we'll see with suitable example for that. For a fetch and add, what is the significance, and swap and compare. So we'll see one suitable example for each command, then we will get understand more clear. Let's see the fetch and add. Let us assume you have a RC, you have a EP, you are writing the. Let us assume you have a RC, you have a EP, you are writing data, membrane, membrane. You are writing data membrane, you are writing data with specific address as a 0 to 7. Let us assume 0 to 7 you are writing the data. That data will be present is a 10150. 50, this data present in the EP side. Now you are sending as a fetch and add command from the RC to EP side. Fetch with add command with data you are sending from RC to EP side. So what happen? What with the same address? It should be same address. That is the limitation actually. So same address means what happen? 0 to 7 you have a data is a 10150. Now you are sending request fetch with add with the data. That data will be assumed as a 56011. What is the previous data? 10150. Now what is the say data you are sending from RC to EP side? 6011. So fetch means it will fetch the whatever data present that particular address. You are giving 0 to 7 address, right? 0 to 7, what is the address present here? 10150 is present in the EP side. This is a fetch command. Then what you have to do? Add. What to add? That data we are sending from the RC to EP side, whatever data present exist in the EP side. What is the existing data? This is the fetch data you got. This is the data you are sending from RTC to EP side. It will add. Add means it will be addition operation going to perform. What is the resulting data? You will get what is it? 10. Let's see here. I will take here. What is the resulting data? 1010011. This is the resulting data you will get. This resulting data it will store and update to the EP side only, and it's the same address it will update. What is the data previous is present? 10150 side. This data is coming from the EP to RC side. This is you will get as a completion with the data from EP to RC side. This is we called as a fetch and add command. By using what happen, you can able to write the data from RC to EP side. Same time you are reading data from EP to side, RC side. So what happen? You are reading, writing both can happen same time. This we called as a atomic operations. Next we'll see the swap command. Swap command is very simple. Just specific location you are swapping the data. Let us assume you have a RC, you have a EP, you have a sending from membrane packet from RC to EP set 0 to 7 address. That data is initially sending as a 10155. Now what you have to do? Next request will be the swapping with the data. So what happen? Whatever data you want to swap that particular location, it will swap. So you will send as a swap command with this data 01010101 data. So you are sending request from RC to EP side. So the 0 to 7 address, that data will be replaced. That what is the data now updated? 01010101 is present across 0 to 7 address. 0 to 7 address. What is the previous data present in the 0 to 7 address? 101 5 zeros. That data is coming from the EP to RC side with completion with the data. So data will be swapped at a time. So whenever you are sending request from RT to EP side, data will be replaced and existing data will be coming from the EP to RC side. This we called as a completion. So memwrite can happen, memread can happen. Both can happening with same command. This we called as a atomic swap command. Now we'll see the one more command as a compare and swap. Now scenario where you have to compare specific location, then it will swap. Comparison done, then only swap will happen. There otherwise there is no change we will see from the completions and memory data. So here it will compare first. Let us assume scenario is for a swap and compare and swap, you should have a length will be the even numbers, whether it is 2, r length will be 4, r length 6, like that. So it should be even number. So let us I took as a here is a 64 bits data I took, 0 to 63. First 32 I will compare first. Remaining 32 will be swap will happen. This is the way swap compare and swap will happen. Let us assume initial data having FF001212. This is the data present. You have a RC. Let us assume you have a EP. Initially you are writing data Z0 to 63 address. This is the data you are written. Assume 1212 FF00 data you are written. The from RC to EP side you are sending as a memwrite. Now we are sending as a second command. This is the first command is completed. Now you are sending atomic operation with the compare and swap command. So you will send a compare and compare swap with the data you will send from the request. So it should be even number. I told length will be the even number. Length means that payload is present that packet. So once you are sending this request, first 32 bits, what is the data is present? FF00. What is the data you are sending from the RC to EP side? This is the data you are sending. What is the data? This is the data. What do you call? 1 2 1 2 FF00. So initially what is the data is present? All ones means FF FF00. This is the data present initially with the RC side. Initial data is present across this 0 to 63 location. You have it. This is the data. Now you are sending. This is the data. So what is the first 32 bits? FF00. You are sending from the request from RC to EP side. What is the data present across from the EP side? First 32 bits FF only, right? This is a FF. FF00. FF00. FF0 is already present. Same data, first 32 bits also you are sending same data. So it will compare what is the existing data and what is the data you are sending first 32 bits. It will compare. If it is same, then remaining 32 bits, what is the data you are sending? 1212, right? First will be the FF00. FF00 you are sending. This will comparison is done. Once comparison is done, that 1212 data will be replaced remaining 32 bits. So this is the data 0 1 2. So this is the data will be replaced once comparison is done. What is the previous data? It's present in same location. We have FFFF, right? FFFF. So 4FF, this is the data coming from EP to RC side with completion with the data. So here is the concept is very simple. Just first 32 bits will compare. What is the data you are sending? What is the data you are sending? What is the existing data? So existing data will be the FF00. First 32 bits. Whatever data you are sending, it should be same. then only comparison will done, right? So if you see come you are sending data with ff00, what is the existed data same location, we have a ff00 only. So comparison will done, comparison will get success. Once comparison done, what happen, whatever the remaining data you are sending 1 to 1 to data, right? That 1 to data will be replaced remaining 32 to 63 location. What is the existed data previously we have FFFF, right? FF data you will get as a completion. So in this way, compare and swap also executed. So what happen whenever you are sending RC to EP side, you have a RC, you have a EP, you are sending request is compare swap with the data, you will get as a completion with the data with previous value. So you are writing the data and replacing and reading also data from specific location. So this we called as a both memread and memread both can happen. This we called as a atomic operation. So in PCA we have it three types. One will be the fetch and add, then will be the swap, third will be the compare and swap. So these three operations helpful to improve the performance. So this is I want to cover in this video. If you have any question, please let me know. Thank you.